This is project 3 video number 2, the one in which we coded up. So I'll fire up the editor. Let's make it so you can see the whole thing. I gotta write a function that returns nothing. Equals get slit. I'll call it get SS, or get the slit spacing of, this might be the fact that it's underlined might mean it might be used for something. So nothing returned. I don't know. I think I'll just leave it like that. See if I run into problems. So no arguments, and then end, and then tab, and we have to say input something. I think I want to work on the attribution already. Percent attribution. It's like I want to get a variable. I think it's something like lambda, the wavelength, equals input of something. Oh, there it is. Prompt. So my prompt is close quote, close parentheses, semicolon to end that line. Please enter the number of meters of the wavelength. So in other words, just a pure number. Please enter the number of meters of the wavelength. So I want to check on MATLAB lambda. No, MATLAB input. Prompt is like a message that I write to get input from the user. So result equals input of prompt. Plays the prompt string, that's something in single quotes, waits for input from the keyboard and then returns the result. Any expression, so I'm just going to put a value in the input. If you press the return key without entering, then okay, so the user has to stick something in. So here they've defined what the prompt is first, and then just made it input prompt. I'll put the prompt right in mine, which should work as well. Put a little space there, maybe that'll work out better if I do that. Yeah, I could put all those Yeah, I'm thinking of how to display it. That it comes out automatically if you leave off the semicolon, but I think I'll put that on there. Alright. Query. Alright, I think it looks good. I'm going to give these guys credit. So, MathWorks. So, used MathWorks page for help with input. Alright, something didn't work out here. There it is. Use MathWorks page, and there's the URL for help with input. Okay, that's cool. I'm going to try keeping it like that. Let's actually see what happens there. If I run get SS, I'm going to save it. Like this so you can see what I'm doing. Oh, I guess it won't let me make it smaller. Get SS. Save. Alright, so oh, I thought it was giving me an error message, but yeah, it seems to be working. 650E minus 9. I thought based on the help that would print that out. So let's work on that a little bit. So go to the end of that line. I'm going to put a colon and a space inside the quotes. And then I'll put oh, I had a semicolon at the end of it. That's why I didn't give it back. So I'll take the semicolon off just to see if it's working, and then I got to put the semicolon on later on. So get SS 650 lambda is equal to 650. Apparently I typed that in with a double L. So yeah, I just want one L there. Alright, I think that's working. I'll put the semicolon back on there so it's not printed out right away. And then x equals input. See, when I say please enter the number of meters, that's just a pure number. If I say please enter the wavelength, then technically somebody should put down a number, and they should put down the symbol M or the word meters. So I think this is a little bit more user-friendly this way. You know, I could say, it would actually be okay to say, please enter the wavelength in meters with maybe without units. You know, don't write the units or something like that. But I think this conveys it. So please enter what is it? The mask to screen distance enter the number of meters from mask to screen, and then a space, single quote, in, put the semicolon there, y input, semicolon, please enter desired number of meters fringe between adjacent fringes. I'll just say fringes. Alright. Then I have to display all that stuff anyway, so I think I'll display it for a while and see how it's working. The display command, let's look that one up. So MATLAB disp, I do remember the name of it. Display text or array. MathWorks always comes up first, it seems. Display X tells you what a variable is. Well, that's what I want to do. Display multiple items on the same line. I'll display a message and the value. So name is Alice. Age is 12 in this one. X is equal to, okay, they've created a one-dimensional array that's got 4 elements. The name, this string, this is num2 string, so it converts the age value to a string. A string is just a list of characters, like what we use to form a word. You know, we could call them letters, numbers, spaces, things like that. And then another one. So they use an array, disp x. Could use sprintf if I wanted to. Or fprintf. Okay, I'm going to go with disp. So disp, you need an array. I want a message. I think I'll call it your wavelength is that's going to be in quotes, and then I'm afraid I forget. Used MathWorks page %. Let's see where I am. % for help with a disp function. Alright, your wavelength is, and then comma, num2 string, num2 string, let's num2 str. Of lambda and then I'm going to try a single quote space meters end quote. You can put a period at the end of the sentence too. And then close. Alright, semicolon. So it prints out stuff to the screen because it's a command that does that, but I don't want to put the semicolon just in case with that it's something extra we go to the screen. So it is an array. My array just has 3 quantities in it, but I did make it an array, so it's displaying this array. It's all characters. This is characters because it's in single quotes. This is characters because that's what num2 string does. And this is characters because it's in single quotes. Let's try it, see what happens. So I'm going to try to make it so that we can see the whole thing. I'm going to try, I might be sorry that I did this, but I'm going to try to close this command history down. Okay. Get SS. That's where I typed in where it ran it, and then it says please enter the wavelength in meters. I want 650 E minus 9. I forget what my example was, might have been 600, I think 3 meters, and then 0.01. So your wavelength is 6.5 times 10 to the minus 7th meters, except I need a space in there for that to look okay. So I'll put that right there in the string. And then might as well get them all. So your mask to screen distance to screen distance is this would be a num2 string of x, and it's also in meters. And then your desired fringe spacing is, and this would be y. So Control S. I want to look at my test case, start using those values. Might as well memorize them. It was 603 and 0.01. 600 times 10 to the minus 9th meters, 3 meters, 0.01 meters. Alright, let's try running it. Get SS 600 from mask to screen was 3, and then 0.01. Your wavelength is 600 meters, your mask to screen distance is 3 meters, your desired fringe spacing is 0.01 meters. So yeah, I messed that up because as a user, I messed it up because that was supposed to be 600 times 10 to the minus 9th, and then that got repeated there. Actually, an output comes in pretty handy. Alright, I think I want to try just creating a line right between here. I think all I have to do is go disp nothing, and then between the input statements and the output statements, just a blank line, just to make it look a little bit nicer. I guess I'm already dressing things up. Hopefully, well, I guess I better check to see if that works. Oops, 1, 2, 3, get SS. Here, not enough input arguments. So let's try a quote with nothing in it. See if that'll work. It didn't do what I wanted it to do. Try a quote with a blank in it. Just thought it would look a little neater with a little bit of line spacing. Alright, I got the line spacing. And I'm right, it does look a little bit neater. Alright, now we actually have to do something. Let's calculate theta equals the arctangent of y over x. Let's make sure I'm doing what I said I was going to do here. Input those, and I've already displayed some of that stuff. Calculate theta and then calculate d. Arctangent of y over x. Okay, let's see. Lambda over sine theta. A tan y slash x. I think I want to make sure of that. So MATLAB A tan, I think it's arctangent. Inverse tangent of radians. Y is equal to A tan of x. So used this MATLAB page. Control V. There's the A tan for up with A tan. I had it, but it doesn't hurt to make sure. And I think I am an editor. Y over x. And then d equals lambda divided by sine of theta. Alright, d equals lambda divided by sine theta, d equals lambda divided by sine theta. Then I gotta display everything. Alright, disp the required slit spacing is comma num to string of lambda comma open quote meters period close bracket for the array, close parentheses to end the function, and let's try it. File, save. No, that's an open. It's already saved. Get SS. Clear command window. CLC. I want to try that. CLC. Clear command. Yeah. Let's see if I can put that in there. I could actually do that instead of that, but I don't know if it's going to work. So we'll leave that in there for the moment. CLC. CLC. Here. You don't have to do that, but I want to try to make it look nice. Plus, I might not do it in the end anyway. I don't know if it's going to work. So, get SS. Yeah, I would say it cleared the command window. And then, actually I'll run through it and then do a get SS. It did clear the command window. 600 E minus 9. 3, and then 0.01. Your wavelength is 6 times 10 to the minus 7th meters. Yeah, it's the same thing as 600 times 10 to the minus 9th meters. Your mask to screen distance is 3 meters, and your desired fringe spacing is 0.01 meters. The required slit spacing is... Yeah, that doesn't look right. So let's, I'm guessing I put a lamp in there instead of a D. I need a D in there. Control S. Try it again. The thing I don't like about this is every time I try it, I have to enter all those numbers. 600 E minus 9, 3.01, point triple odd 18 meters. What did I get? That's one, yeah, point triple odd 18 meters is exactly what I got. So I could convert that to millimeters and print it out in millimeters if I wanted to. I actually think I do. So /123 and then mm. This would be kind of cool. You gotta do this one. /10. No, /100. Put it in centimeters. Your wavelength is, divide that by 1E9 and put it in nanometers. Don't have to do that either. I feel like it. (600 E minus 9), 3 meters, 0.01. Oh boy, I'm going the wrong way with all of them. So let's fix that up. times. Yeah, I'm going to have a lot more of the little things than I did of the meters. Okay. (600) minus 9 3.01. So 600 nanometers, 3 meters, 1 centimeter, and the answer is 0.18 millimeters. I like it. I think we're pretty much done with the programming part. So it's working for my test case. If you're curious, you know, for 720 nanometer light, 720 E minus 9 at 2 meters, let's say half a centimeter. Then I have to put the slit spacing, make the slit spacing 0.288 meters. So it does work with different numbers. I guess I haven't proved that it gives the right answer with different numbers, but at least it functions with different numbers. And I did have a test case that worked with a test case. It's not a good idea to try every case. There's an infinite number of them, so you couldn't. Alright, I think it looks pretty nice. You could make these semicolons line up. But, yeah, I think I'll try that. I'm going to put semicolons after, or colons, then colons. Colon. I'm going to see if I can make them line up too. So just include some spaces in the string. And then it might look a little bit better if I try that here too. Let's see. So 550 E minus 9 2.5. I'll go back to my 1 centimeter. Your wavelength is, so everything lines up except for the wavelength. We got to put a colon in for that one too. Didn't do anything with that one. And then, and I think I'll go disp. Open quote. Just try drawing a line across. Separate my answer from the other pieces. Yeah, let's see if I broke it. I'm going to enter a bunch of nonsense. And just looking at the format. Then I wanted this one to line up with it as well. Oh, I see what it is. I think to see how they line up, I got to put the word input. same spot for all of them. So it's just a coincidence. Let's see. This one needs to be moved over to there. Control S. Oop, there it is. So, I see. 1, 2, 3. So a bunch of nonsense. That double slit spacing wouldn't work that way. That wavelength is ridiculous. You know, it's not in the visible. But just for what things look like, yeah, I think it looks pretty nice. Probably could do with about 3 fewer of those lines. If we cut those out, yeah, I'll get rid of 2 of them, and then test it for real too. So make sure it's still working. In other words, put realistic numbers in. 600 E minus 9 3.01. This is the one that's supposed to give me 0.18 millimeters. And yeah, that looks good. Required slit spacing is 0.18 millimeters. I'm happy. I want to make sure I didn't say that you had to print them out in meters. Calculates and displays, prints to the screen, but a summary of the values supplied by the user and the required slit separation with units, but I didn't say in meters, so I can use whatever units I want, as long as they're fairly appropriate. I mean, don't put it in inches, for instance, in a clear, easy to read, self-explanatory format. So it might be cool to say welcome to this program, but I think I'm happy with the way it is. Please enter the number of meters of the wavelength. Please enter the number of meters from mask to screen. Please enter the desired number of meters between fringes. Your wavelength is, your mask to screen distance is, your desired fringe spacing is, all with units, and the required slit spacing is with units. Alright, that does it for video number 2.